The universe we know has always been a silent movie. We've spent millennia watching the cosmos, but we've only been seeing the flashes of light. For all of history, our picture of the universe has been painted with light, from radio waves to gamma rays. But the most titanic events in the cosmos, like the collision of two black holes, happen in complete darkness. They release no light, no afterglow, nothing for our telescopes to see. We've been staring past the main event, catching only faint echoes. This has left us blind and deaf to the universe's most powerful moments. To truly understand the cosmos, we need to stop just watching and start listening. We need to listen for gravitational waves. So, what are we listening for? Not sound, but ripples in the fabric of space-time itself. Albert Einstein predicted them over a century ago. Picture space-time as a giant, flexible sheet. When massive objects, like two black holes, spiral into one another at incredible speeds, they create waves that travel outward at the speed of light. These are gravitational waves. As they pass by, they stretch and squeeze everything in their path. The distortion is almost impossibly small, far less than the width of a single atom. Detecting something so subtle requires an extraordinary instrument. Enter LIGO, the Laser Interferometer Gravitational Wave Observatory. It's a pair of giant L-shaped detectors, with arms stretching for kilometers. Lasers are fired down these arms and bounced between mirrors. When a gravitational wave passes through, it stretches one arm while squeezing the other, knocking the lasers out of perfect alignment. That tiny mismatch is the signal, the cosmic chirp of a distant collision. Hearing that whisper changes everything. Gravitational wave astronomy gives us a new sense to perceive the universe. We can now directly observe the collision of black holes, events that are completely invisible to any telescope. We can probe the secrets of the early universe, from a time before light could even travel freely. And we can measure the expansion of the cosmos with a completely new and independent method. But listening to these cosmic whispers isn't easy. The signals are incredibly faint, buried in a sea of noise. On Earth, the slightest tremor, a distant earthquake, or even a truck driving down the road can drown out a signal from a billion light-years away. It takes incredible engineering to isolate the detectors, and powerful AI to sift through mountains of data to find that one telltale signature. This is just the beginning. With future space-based detectors like LISA, we'll escape Earth's noise entirely. We're turning the silent movie of the cosmos into a full, immersive symphony. For the first time, we are not just watching the universe, we are listening to its dark symphony.